or rather, so this is, if you have a specific question you can ask, I'll try to answer, but again, your best bet is to post something on Piazza, because if you haven't figured out yet, these things are, there is a lot of detail involved, and so trying to understand all the details and answer them in the classroom is often not feasible. But if you have any higher level questions, certainly ask them. Or if you're not sure it's a higher level question, you can still ask the question, and then I can say whether it can be resolved here or not. Okay, so the class is doing very well, so we will I'll take that as an encouraging sign. Yeah.
If you're going to print the address of a function,
Yeah.
In GDB we type p and the function name, so that gives us the address of the function.
Yeah.
But regarding functions which are not used in the program, example execl
Yeah.
or system. So
Execl is used in the program.
For example, system.
Yeah.
So when I was printing the address of the function inside GDB, it was
Yeah.
giving something like B7 or something.
Yeah.
But when I was printing it in, say, outside GDB or in program itself by printf,
Right.
then it was giving something 080, which is where I think the program address should be, because all the code memory is starting with 080 something.
So,
So I was wondering.
so I don't know exactly what you are saying, because so you will so for execl, right? So in one of the responses to a question, right, I pointed out that the way you make calls to other libraries, right, is if you want to call f that is in a library, what your compiler does is it creates a call to f at PLT, okay? And PLT is a piece of code that the compiler will automatically add, okay? And the PLT will contain essentially a stub for every function that you want to call. So, so f at PLT will be defined to do something like call star, something like this, right? Basically, what it is doing is it is using a table which should contain the real address of f, okay? And it's going to jump to that location. It won't be a call, it'll actually be a jump. Okay? So this table needs to be set up by the linker. Okay? The linker will fill in this table, so the compiler doesn't have to know where is f actually, because obviously the compiler is compiling this one little program. It doesn't know where is this other library, right? So it just creates this stub, and it knows that this location, memory location, will be filled in by the linker, and then the call will go. Okay? So if you are looking for the address of f at PLT, then that will be at your 08 whatever address, right? But f itself will be somewhere else. Okay? And when you use ASLR, that library is going to be mapped at different locations each time you run. Okay? So the location of f is going to change across each run. Okay? And that is probably what you observe. If you go back and check for this, it'll make more sense. Okay? And somebody pointed out that calling, the way the vulnerable program is set up, calling execl is a little difficult in the bonus part of stack smashing. how to do that. That's a little bit more, that seems difficult to do. So I will post a modification to the bonus problems on Piazza, and you can see, and that modification should be possible for you to do. Okay. Of course, you don't have to do the bonus part, but if you are looking to do it, then I'll post an update. Yeah. Yeah. If you can speak just a little bit louder, yeah.
The coding is the simple statue I think where the injector will cause the only function.
Yeah.
And I'm able to then start, way to start that call.
So, I mean, what you need to do is you need to go into GDB and look at it in assembly, right? And that's when, that's how you'll be able to debug it, right? So what is happening, is it able to, are you returning to some place, or even the return hasn't succeeded?
Actually, you have to write some code in the buffer, right? So that
Yeah.
the stack has to.
Right.
What is the code we have to write? Is it like the when a function call happens, it starts with push EBP and all.
You don't have to do any of that, right? You just want to jump to own me, right? That's all you need to do. You can write code which jumps to EBP. I mean, jumps to own me, right? So if you see the tips, it'll tell you that it's difficult to. That I recommend that you try to make an indirect jump. Through using a register. You first store, load the address into a register and then do an indirect jump. That'll be your the injected code. Okay, I think. Right. So, but what you need to do is you need to first make sure that you step through your program, right? And when you are about to get to return, right, you should go to the assembly mode display, and then step through an assembly. And when you are about to return, check what is the address to which you are returning, and make sure that that is the address that you intend to return. And then if you step, it will return and go to that place, right? And then you check whether your instruction is there, right? And you'll have these issues like big endian, little endian, and so on. And I can never remember what is what, so I always just go into the GDB and then check whether things are in the right order. If they are not in the right order, then I know my order is wrong. I change it around, and then it works. Okay, it's definitely there are only like 6 bytes of code that you have to write. Okay, and remember I told you that because the exact locations will be hard to predict. Okay, you will always be off by a few bytes. So then you're going to use this no-op sled, right, to sort of make sure that you fall through that no-op sled and then jump into the actual code. But the actual code itself will be only like 2 or 3 instructions, and then so you need to see whether the critical thing is that you be in assembly mode display in GDB when you do the return, right? And by the time you reach the end of the function, you should be in assembly and then step through and then jump. Okay, so that then you'll also see, for instance, if you got your canary wrong, right, or the canary is in the wrong place, then it won't go to the return, right? It'll just you'll do the stack check, and then it'll call this other function called stack check fail, and so you'll be able to see all of those things that don't work if you are in that GDB assembly mode. Anything else? Yeah, keep working at it, and these things have a property that it looks difficult until it's done. It feels like you're not making progress and then suddenly, it's done. Okay. So keep at it, and then come to our office hours if you're having trouble post on Piazza. So there's already a lot of discussion, so you'll see if you go through that, it may already answer many of your questions. If not, post more questions and we'll answer them. Anything else? Okay, so let's continue.